Alright, and welcome to completing the square when a doesn't equal 1. Now for example 1, we have p of x is equal to 5x squared plus 10x minus 3. And if you were to try factoring by grouping this, you would say, okay, well 5 times negative 3 is negative 15, our a term times our c term. And then you would say, well, wait a second, what pairing of 15 has a distance of 10? Well, 1 and 15, see, that has a distance of 14, so that wouldn't work. 3 and 5, that has a distance of 2. Well, it actually looks like you can't use factoring by grouping here. So, what I'm going to show you how to do is how to complete the square when a doesn't equal 1. Okay, so let's see. We're going to do our normal thing. Say, you know what? P of x is equal to 5x squared plus 10x. And we're going to leave a little space here and put a little minus 3. Now the thing is though, we can't create a perfect square when we have an a term that is not equal to 1. Remember, that is always a problem when a doesn't equal 1. So the only major difference here is that we are going to factor out the greatest common factor. So for instance, let's go ahead and switch colors here. If I said what is the largest number 5 and 10 can both be divided by, well, you would say 5. And so what happens when I divide both of these by 5? Well, 5x squared divided by 5 would be simply x squared. And 10 divided by 5 would, of course, be 2x. And we'll leave that space and put that minus 3. Now from here, it's pretty straightforward. We know that we want to create a perfect square by using b over 2 squared. And in this case, our b term is 2. So we have 2 divided by 2, which is 1. And 1 squared, which is still 1. But notice, here's our new thing. And this is what you have to be so careful of. This is not actually 1. It's actually 5 times 1. So you have to say, well, wait a second. What is 5 times 1? That's positive 5. So to balance it out, we need to put a negative 5. And that, once you understand that, these become so easy. Okay? So we really have p of x is equal to, I just write my 5. Remember, to go from this to a perfect square, I simply write x, and I divide my b term by 2. 2 divided by 2 we know was 1 squared. And then, of course, on the outside, minus 3 minus 5 is negative 8. And there you go. We've just completed the square when a doesn't equal 1. And the only real difference is that you'll have some sort of coefficient here in front. Let's try a second example and move a little faster. Okay, let's take a look at example 2. Now, just humor me. What if I said, hey, I want y'all to try and use factoring by grouping? Could we do 3 times negative 1? Let's see, that would be negative 3. And can negative 3 break down into any factors that add up to be negative 12? Well, let's see, my only options are 1 and 3. And yeah, there's no combination of 1 and 3 that can get us to negative 12. So in this case, we're going to have to complete the square by factoring out our a term. Okay, how do we do this? Once again, kind of like normal, we'll write our first two terms, 3x squared minus 12x. We'll leave a space and put a minus 1. Okay, and while I'm at it, let me just go ahead and erase that. Okay, now from here, remember, we cannot create this perfect square unless a is equal to 1. And currently, a does not equal 1. So we're going to factor out our GCF. And notice we can divide both of these by 3. So I'll put a 3 on the outside. And when we do 3x squared divided by 3, oh, sorry, wrong color, well, that just leaves us x squared. And negative 12 divided by 3 is negative 4x. And now we can create our perfect square. So notice, as always, we'll use b over 2 squared. Our b term is negative 4 over 2 squared. And negative 4 divided by 2 is simply negative 2 squared. Now we know negative 2 times negative 2 is positive 4. Now here is where you are likely going to make your mistake. This is a positive 4. This is a positive 3. We're really saying 3 times 4. 3 times 4 is 12, okay? So in order to balance out a positive 12, we need to put a negative 12 over here off to the right and not a negative 4. So be very, very careful that you're paying attention to that little bitty step. So now we have g of x is equal to 3 parentheses, and remember to turn this into a perfect square, well, let's write x and then take our b term and divide by 2. Negative 4 divided by 2 is negative 2 squared, and negative 1 and negative 12 is negative 13. Alright? I'm going to go ahead and do one more just for anyone who's still confused, but please finish your notes first. Alright, y'all, here's our third example, and let's check it out. Once again, we're going to have to complete the square when a does not equal 1. So as always, we'll do parentheses minus 4x squared plus 16x, leaving our space, parentheses, plus 3. And here we know we can factor out a negative 4 from both of these. What is that going to look like? H of x will equal negative 4 once we factor it out, parentheses, x squared, and wait, a positive divided by a negative is a negative 4x. Leave our space, good, plus 3. Now you're going to notice here our b term is negative 4, so when we do b over 2 squared, we'll have negative 4 over 2 squared, which is negative 2. Okay, fine. Negative 2 squared is going to be negative 2 times negative 2, or aka plus 4, and here is where y'all need to be so careful. That's really, this number is not just positive 4, it's positive 4 times negative 4. So positive 4 times negative 4 is actually negative 16. We need to balance it out with a positive 16. And from here, as soon as y'all learn that little trick, that little nuance, the rest of this is so easy. We know that to turn this into a perfect square, we'll simply write x minus half of our b term, x minus 2 squared, and 3 plus 16 will of course give us 19. By the way, what if I were to ask you to give me a rough sketch graph of this? Could you do it? Well, at this point, having seen our last lesson, I would hope so. What would we say? We would say that our vertex is going to be where this x value makes this factor equal to 0, positive 2, and this positive 19 is the y value of our vertex. So if I go over here 1, 2, and up 19 units, I'll put that, and notice our a term is negative. Our graph will look something roughly like that. Alright, let's move on to our next video.